Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here we are given with this rocket that blasts off from this position and it moves straight upward with an acceleration of 12 meter per second squared until it reaches to a height of 29 meter. So let me show it in the figure. So up to this height, let this height be x1 and this is the initial position. X0 is equals to 0 and now this distance is 29 meter. Now up to this distance the acceleration is 12 meter per second squared, and after this position the rocket is in free fall. Now we'll be considering this direction to be our positive direction. Now so after this position the engine is shut off and it continues to move in free fall. This is what we are given. Now there are three parts in this question that we need to solve. In the A part we need to find the maximum height attained by the rocket. So we're going to proceed with the part A first. So let us suppose that at this position the velocity becomes 0. So this height, this total height would be the maximum height attained by the rocket. So this is what we have to calculate in the A part. So for that we'll be first calculating the velocity of the rocket at this position where the engine is shut off. So let the velocity at this position be v1. So what equation we can use? We can use this equation, which is v square minus v naught square is equals to 2a delta x. Now this is v is the final velocity, which in this case is v1. So v1 square minus, now v naught is the initial velocity. It started from here where the velocity was 0. So v naught is 0. So this is 0 square is equals to 2 times, now acceleration is 12 meter per second squared and its direction is in the upward direction. So this would be a positive value we have to take because we have taken this direction to be positive. So A as it is. Now delta x we have 29 meter. So right now I'm just writing delta x. So v1 would be equals to under root 2 times A times delta x. This would be the expression for the velocity at this position. Now we can substitute the values to find the result. So v1 is equals to under root 2 times acceleration is 12 meter per second squared multiplied with delta x, which is 29 meter. Now it's pretty simple. You can use your calculator to find the result and this would be 26.4 meter per second. So this would be the velocity at this position. Now next we know that here the velocity becomes 0. So we can do one thing. We'll be finding this distance first. Then we're going to add this 29 meters to this distance to find the total distance. So let this distance be delta x. Now again we can use this equation but for this from this point to this point. Okay. So here this is the final velocity, which is 0 in this case. So this is 0 minus. Now this would be the initial velocity in this case, which is v1. So v1 square is equals to 2 times now acceleration. Now since the engine is in free fall during this time interval, so acceleration would be a equals to g, and since it is the acceleration is in downward direction and we have taken this direction to be positive, so negative sign should come here. So 2 multiplied with minus g times delta x. Now from here the expression for delta x would be equals to v1 square divided by 2g. Now we can put the values. This v1 square is 26.4 meter per second and its whole square divided by 2 times, now g is 9.81 meter per second squared. It's pretty simple. Now you can use a calculator to find delta x, and delta x comes out to be as nearly 36 meter. So this distance comes out to be 36 meter. So the maximum height achieved by the rocket will be, this is x max, this would be equals to x1 plus delta x. x1 we have 29 meter. So 29 meter delta x we have calculated just now, 36 meter. So that would be equals to 65 meter. So this would be the answer for the A part. Now next we're going to solve the B part. Now in the B part we need to find what is the speed of rocket just before it hits to the ground. Now after reaching the maximum height, the rocket will move down like this. So here the velocity is 0, and here velocity, let it be v final, that we need to calculate, and this total distance we have 65 meter. Now to find the final velocity, again we're going to use this equation but for this time interval when it is moving down. So let me first write the equation first, which is v square minus v naught square is equals to 2 times a times delta x, which is xf minus xi. This is delta x. Now we can put the values. Now this v is the final velocity, which is vf here, that we need to calculate. So vf and it's squared minus, now v naught is the initial velocity at this position, so v naught would be 0, so 0 square is equals to 2 times, now acceleration, since we have taken this direction to be positive and acceleration is in downward direction, so a would be minus g. Now xf, this is the xf, this would be xf, which is the origin only, so xf would be equals to 0, so 0 minus, now xi is this distance, this distance is xi, this total distance, which is equals to 65 meter. So we can put it as 65 meter here. Now vf would be equals to 2 times g is this is 9.81 meter per second squared, and this would be minus 65 meter and square root. Now again we're going to use our calculator to find the answer, and this comes out to be as nearly 36 meter per second. So this would be the answer for the B part. Now next, the final part is left, which is the C part, where we need to find the total duration of the rocket's flight. So total duration means when it moves up and then it moves down. This would be the total duration. So we're going to split this duration into 3 parts. This is the T1, where it started from origin and reaches to the position x1, and in between this time interval the acceleration is 12 meter per second squared. Now after this position the engine is in free fall, so let this time be t2, where it reaches to its maximum position and then come back to its original position. So let from this point to this point, let the time taken be t3. So the total time of flight will be summation of t1 plus t2 plus t3. So we're going to calculate t1, t2, t3 one by one. So t1, so this is t1, from this point to this point the time taken will be t1. Now to calculate t1 we can use the concept of the average velocity. We know that the average velocity is equals to 1 over 2 v plus v naught. This is we studied earlier. So t1, when the rocket was moving up, so this would be delta x, the distance traveled during this time interval, divided by the average velocity. So 1 over 2, v is the final velocity, which in this case is v1. So v1 plus, and v naught is the initial velocity. Now for t1 delta x is 29 meter. So this would be 29 meter divided by half. v1 we have equals to 26.4. So this is 0 plus 26.4 meter per second. Now you can use a calculator to get the result, and that would be equals to 2.2 seconds. Similarly, we can use same concept to find t2. So t2 will be equals to delta x over 1 over 2. This is the two velocities we have here. This is v1 and here this is v. So v1 plus v. So delta x in this case is 36 meter, I suppose. Yeah, 36 meter. So this is 36 meter divided by 1 over 2. v1 is the velocity, which is 26.4 meter per second, and v is the final velocity, which is 0. So that would be equals to nearly 2.7 seconds. Now T3. Now in this time interval, the engine, the rocket is moving down. So same formula, delta x over 1 over 2. Now velocities we have, this is v here. When it is moving down, the velocity here, the velocity is 0, and here the velocity is vf. So v plus vf. So delta x in this case would be the total height, which is 65 meter. Divide by 1 over 2. Now the initial velocity is 0. Here, let me show it in the figure. Here the initial velocity is 0, and final velocity becomes vf, we calculated earlier, to be 36 meter per second. So that would be 36 meter per second. Now you can use your calculator to get the result, and that would be equals to 3.6 seconds. So the total time will be summation of all t1 plus t2 plus t3. So t1 we have 2.2. So 2.2 plus 2.7 and then 3.6. So this would be equals to 8.5 seconds. This would be the total time of flight.